So today's lesson, we're going to utilize the vocabulary that we had last time. So it was that large piece of paper with all of the vocabulary words on it. We're going to discuss how to actually answer questions about the things instead of just being able to say whether something is going up or going down. We're going to actually discuss how to write that math-wise. But first, we're going to go over even and odd. Remember, even and odd is not like the power or not the degree. We're talking about the shape of the function. So for these kinds of questions, we need to look at the shape of the graph. Right now, I need you in your calculator, and yes, your calculator, not Desmos, please, we got to get used to these calculators, to graph this. Now remember with the calculators, there's already y equals typed in, so you skip the y equals, you skip the f of x equals, you just type the equation part down. Once you have it typed into y equals, you press graph. What does this shape kind of look like? A squiggly line. Does that squiggly line go through the origin? Yeah, okay, so when we sketch this, we're just going to do a sketch. So it doesn't say accurately graph. If it said that, we'd need to plot a whole bunch of points. But hopefully your graph kind of looks something like this, right? Yeah. It looks better than the one I just drew on this paper because obviously a computer graphed it on your calculator and it can be more accurate. The question here is to determine whether the function is even, odd, or neither. So if you look at your vocabulary list from last time, what does it mean for a graph to be an even graph? Yeah, the even functions fold along the y-axis. Based on your vocabulary list, what does odd mean? Yeah, it's going to rotate around the origin visually. So in this problem, the red graph that we have here, if I were to fold it along the y-axis, which is this right here, does it land right on top of itself? No, can't fold it. But if you put a pin in the origin, stick it in the origin, and rotate it, does this side land back on this side? Yeah, especially if I drew it better, like your calculator drew it. So that means that this function is an odd function. Has nothing to do with the degree of the polynomial, really. It has to do with whether it is actually symmetric about the origin. But that's kind of the gist of how you answer these questions. So our next one says, is g of x equal to x to the fourth plus x squared plus 1 even, odd, or neither? So we need to see what it looks like. I will give you a second to type it in your calculator so you can see what it looks like. Go for it. But this quartic actually kind of looks like a quadratic. And if you were to sketch it pretty accurately, it's going to do something like this. Doesn't go through the origin. I made sure I put it at 1, which is where it goes through. Okay, so this graph, can I fold it along the y-axis and make it land on top of itself? Yeah, and if that's the case, it's called an even function. That's it. Even, odd, or neither can be a visual idea or an algebraic idea, and we're sticking with the visual idea here. But you might have a graph that looks like this one, and we have a different option. So let's go ahead and graph this one. X cubed plus 2. It's a cubic function. What does this one look like whenever you graph it? Another squiggly line, which makes sense since it's cubic, but does it go through the origin? No, it goes through 2. So if I were to actually graph this or sketch it, it would look something like this. Okay. Can I fold this along the y-axis and make it land on top of itself? No. Can I put a pin in the origin, not the y-intercept, but the origin, and rotate it? No, because it doesn't even go through the origin. When it doesn't go through the origin right here, that's a problem, and it's never going to be odd because it has to go through the origin. So this is neither even nor odd. So not all graphs are even or odd. In fact, most graphs are neither. But there are specific graphs that are specifically even or odd, and it's very important to know when you have those. Now, what I'm going to have you do later on, and it's mostly on the back side of this, is find the actual maxes and mins on a TI-84 calculator. And the buttons are different. On Desmos, it always tells you the maxes or mins. You just poke them, beep, beep, and then they tell it to you. But you are going to get a calculator on your next test / your SATs are coming up, juniors, and you only get a calculator. There is no Desmos. So we need to know that skill on here as well. So everybody pick up their calculator right now, and I want you to just press second trace, like the buttons say on your notes. It brings up a menu. What is option number 3 on that menu? Oh, number 3? It says minimum. That's what we're going to be using to find minimums. What does option 4 say? Maximum. So that's how you find the program that helps you identify maxes and mins. I'm going to help you do this right now. I need everybody to type in the following equation. Y equals x cubed plus 2x. Okay, type that into your calculator. We're just going to find these maxes and mins together just so you can see how to use these functions. Oh, I'm sorry, it should be minus 2. X cubed minus 2. So just to edit these so that they actually sit, you're supposed to do the right or the left side first, and then the right side.
So second trace 3.
Second trace 3 to find the minimum, and then follow the instructions on the screen. Go to the left side of the minimum, which you might already be on the left side of the minimum. Go to the right side of the minimum. Don't guess, so you just bypass that screen, and then it tells you a coordinate point. Some of these minimums might be pretty, they might be whole numbers, but there's something important that you need to know. Your calculator tries to flex its math muscles too much, and occasionally you will get a number that has an E at the end. If the number has an E at the end, it's using scientific notation. Most of the time, I think 99.9% of the time when your calculator does that, the E, if you see it, really just means that number is 0, because it's such a small, delicate number that you might as well make it 0. So if you see an E on your calculator when you're doing this, it's just the calculator being extra. It's 0. Additionally, rounding might be necessary, as you saw, because a lot of these maxes and minimums are not going to appear at pretty points. They're going to appear at just some random points. Okay. So here we go. Here's putting it all together. We're going to take a graph. For the first one, we're going to graph it. For the second one, I've already graphed it for you. And we're going to list out all of the attributes for this graph. But we're going to do this in a smart way. We're going to work smarter, not harder. The way we're going to work smarter, not harder, is by looking at the zeros of this function. This particular 0, this factor, tells me that there is a place where this graph crosses the x-axis right here. Why do I know that? Why did I put this dot right here? Because it's the opposite of negative 2. That means 2 is right here. Additionally, because this is squared, it's a repeated root. What's going to happen here? Am I going to cross through the x-axis, or am I going to bounce off the x-axis? Bounce. If you look back at your vocabulary notes from last time, this is going to bounce off the x-axis here. From the other parentheses, from the other factor, where should I put my dot on the x-axis? At positive 5. Very good. And since that one has a degree of 1, we're going to be able to cross through this one. So I'm going to put the word cross right next to it. Okay, cool. I haven't done any thinking beyond changing some signs and bouncing and crossing. The last thing we need is a y-intercept. The way that we're going to get the y-intercept is by utilizing the calculator. So right now I need everybody to type in this equation, the f of x function, into your calculator. And we're going to find just the y-intercept, because we already found the x-intercepts. We don't need that. We already found the zeros, so we don't need to find them on the calculator. We just need the y-intercept. So x minus 2, square that parentheses, open another parentheses, x minus 5. Now when we press graph, visually the y-intercept is off screen, correct? So what we need to do is go to our table. How do you get to the table button? Second and then graph. Now that number that is partnered with 0 that should show up right away, what is that number? 20. That means that all the way at 0, negative 20, that is going to be where our y-intercept is. So it's off screen. But now we know where our y-intercept is. Fabulous. The next points we need to be able to be very accurate with our graphs are any maximums and minimums. So if you look back at your graph, there is a maximum at 2. We already saw that because of the bounce. But isn't there a minimum in between that and the next 0? We need to find that minimum. So what buttons do I press on here for it to calculate the minimum for me? Second, trace 3. And it's going to ask you to put the turtle on the left side of the minimum. Now, I want you to click until you actually see the turtle. Right now, your turtle is off screen, and that's okay, but click around until you find the turtle and put it on the left side of that minimum. Let me show you what I mean. The calculator tells us that this minimum is at 4, negative 4. That's our minimum. Once we have these points, we have our x-intercepts, our y-intercepts, and all of the maxes and mins, we can play connect the dots. Start at the y-intercept, or the furthest point on the left. You go up to the bounce, and you're going to bounce off that point. So I come back down, don't cross it. Go through the minimum, and then go through the point that says cross. I'm going to do that again because I think some of us were looking down at our own papers when that happened. So let me do it one more time. So we start at the y-intercept because that's the furthest point to the left. We move up. This first point says bounce, so I have to bounce, and I have a minimum. The second x-intercept says cross, so I can cross through it. And we've played connect the dots. Obviously, it looks like the one that's on your calculator screen, so you all honestly know what the shape should look like. But if you didn't have that, that's how you would know. Matches up with what we know about end behavior, this being an odd positive, and all of those things. Okay. We list out all of the attributes. The y-intercept we already said was 0, negative 20. So the y-intercept should be a coordinate point. There is a possibility that when they ask you for the y-intercept, they just want this number. So it kind of depends on how the question or the answer choices look. So it's usually a coordinate point, could potentially just be a number. Same with x-intercepts. You have an x-intercept at the coordinate point 2, 0. And at 5, 0. But there is a strong possibility that when you're answering this question, it just wants these numbers. So that's totally an option for how 2 ways you can write your answer, as a full coordinate or as a point, as a number. The next thing we're asked for is the increasing and the decreasing intervals. What did that mean when we're talking about increasing intervals? Think about the vocabulary list. What did we mean by increasing? It has to do with the turning points, sort of. What does the word increasing mean? Up. It is literally the part of the graph going up. How many parts of this graph are headed upwards? 2. I'm gonna color those in. So I have this section right here that is going up, and I have this section right here that's going up. I would highlight those if I were you. Those are my 2 sections where the graph is going up. So I need to talk about that interval. The interval means I'm talking about the x values. These x values go from negative infinity all the way to what number? Where does it stop going up? 2, because that bounce number is right there. Okay, the second time it goes up, it starts going up at what value? 4, because that's where the minimum is. And it stops going up all the way at infinity because it goes off screen. So the way that we write this answer is in interval notation using those numbers. We'd say the increasing interval is from negative infinity to 2. And that's a U in the middle. Union means or from 4 to infinity. The 2 and the 4 come from the x-axis, come from those x-intercepts. And the minimum value has everything to do with your maxes and mins. Our decreasing interval is the section of the graph that goes down. There's only one little section in here that goes down. What two numbers are on the endpoints of the part that goes down? We're looking at x values, not quite y values. So again, we're looking like here. 4 will be one of them because that's when it stops going down, but where does it start going down? 2. The decreasing interval is from 2 to 4. That's the little section in the middle where this graph goes down. Now we've talked about the local maxes and mins. It really just wants the coordinate point. We know that local maximum value is the number 2, 0. Sorry, that one does have to be a coordinate point. There's like no other option for how you talk about minimums, unless it says minimum value. The local minimum we just found in our calculator to be 4, -4. Or 3.9 repeated if you're Fabrizio's calculator. And then we have to answer even, odd, or neither. This graph that we have here, can we fold it along the y-axis?
No.
Can we rotate it around the origin and have it be symmetrical? No. So what is this one called? Neither. There's a lot of parts of a polynomial function that we have to be able to talk about. So let's try it one more time because I know that that was confusing. This one we don't even have to graph. It's already graphed for us. Woohoo, that's nice. So let's do a few things to this graph before we start listing things out. First of all, where are the zeros of this function? -2. Okay, I'm just going to list that number out because it's helpful. And where else? At 1. Fabulous. So we already know where the x-intercepts or the zeros are going to be. Where's the y-intercept? 2. Does this have any maximums? Yeah, the maximum would be here, and we don't have it in our calculator to be able to run our program, but we can count. This is at the coordinate point -1, 1, 2, 3, 4. Does it also have a minimum?
Yes.
Yeah, where is that minimum? 1, 0. So that coordinate point plays double duty again as both a minimum and a 0. The last thing I'm going to do on here, and I know that now I'm using the same color, so actually I'm going to switch these colors to purple real fast just so I think it'll be less confusing. Okay. How many sections of this graph go up? Going up, there's 2 sections. So we have this section right here where it goes up, then it stops and it goes down, and then it stops again and it goes back up. So at all of the turning points, it's going to turn directions and change directions. Okay. We want to identify the x values where those turns occur. So what I'm going to have you do, and I think it will help you, I want you to take your pencil and put it on the maximum and draw an arrow straight down to the x-axis. Because that number is going to be very important for where the change happens in our increasing and decreasing intervals. Okay, we start listing some things out. The y-intercept we found to be 0, 2. That's where the graph crosses the y-axis. The x-intercepts are at -2, 0 and at 1, 0. I like putting them in number order, and believe your homework also asks for them to be in number order. Our increasing intervals need to be the green sections of the graph. The green section of the graph kind of goes off screen, which means it starts at -infinity. Where does that first section stop increasing? So it's increasing, it's increasing, it's increasing, it stops. What's the x value right here? -1. So that's going to be the next number in that little parentheses. And then we pick up our pencil because we'd have to go down. Where does the next green part start? What is that x value? 1. So my next coordinate point here is from 1 to infinity. The decreasing part is just the stuff in the middle. What's the x value where it started decreasing? -1. Where did it stop decreasing? 1. So literally, if you notice, these are the same numbers, and they always should be the same numbers. If they're not, you've done something wrong. That's a good thing to notice here. And then we get to maxes and mins. We've already listed those out, so that's easy. Our local maximum is at -1, 4. Our local minimum is at that coordinate point 1, 0, playing double duty. And is this graph even, odd, or neither? Neither again, because you can't fold it, and it doesn't go through the origin to be rotated, so it's going to be neither.